Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rohini College of Engineering and Technology. I am going to handle the subject on Communication Engineering. Now I am going to discuss about the topic on Degrees of Modulation. After completion, the students will be able to what are the types of degree of modulation, define under modulation, define over modulation. So first we have to discuss about the degrees of modulation. The modulating signal preserved in the envelope of amplitude modulated signal only Vm less than Vc, then Ma less than 1. Depends upon the amplitude of the modulating signal. This will be relating to carrier amplitude. Degrees of modulation is classified into three types: under modulation, critical modulation, finally over modulation. First we are going to see about under modulation. So in that thing, the modulation index Ma will be less than 1 and Vm less than Vc. So the envelope of AM signal does not reach the zero amplitude axis. Therefore the message signal is fully preserved in the AM envelope. So the envelope detector can recover the message signal without any distortion. That is, in this diagram we are seeing the undermodulated AM signal, that is in the center. This will not reaches the zero value. So this is undermodulation. Then critical modulation. So modulation index Ma will be equal to 1, then Vm equal to Vc. So for Vm equal to Vc, the modulation goes to 100%. This is known as critical modulation. So the envelope of the modulated signal just reaches the zero amplitude axis. So the envelope detector can recover the message signal without any distortion. So now we have to see the critical modulation diagram. So in that thing, the center, the waveform will be reaches the zero axis. This is critical modulation. So in that over modulation, Ma will be greater than or equal to 1, then Vm greater than Vc. The portion of envelope of the modulating signal crosses the zero amplitude axis. Due to this, envelope distortion occurs. So the envelope and the message signal are not same. So both positive and negative extension of the modulating signal are cancelled or clipped out. So if you are seeing the over modulation, in the center the distortion will be occur due to over modulation. So this will be only crosses the zero axis, but this will be having some distortion. So then AM power distribution. We know that AM signal has three components: unmodulated carrier, then lower sideband and upper sideband. Hence the total power of AM wave is the sum of carrier power and powers in the sideband, that is PUSB and PLSB. That is, we have to calculate the total power, that is PT will be equal to PC plus PUSB plus PLSB. So we have to take the equation 7. So based on this, that is Vam of t will be equal to Vc sin 2 pi Fct plus Vc into Ma divided by 2 cos 2 pi Fc minus Fm of t minus Vc into Ma divided by 2 cos 2 pi Fc plus Fm of t. So next we have to calculate the average power, that is RMS voltage divided by load resistance. That is, power will be equal to V divided by root 2 the whole square divided by R. So the power will be equal to V square divided by 2R. For carrier power, PC will be equal to V square divided by 2R. So this is the power spectrum of amplitude modulation. So that is, the graph will be drawn between the amplitude and the frequency. So center we are having the carrier frequency. In the side we are having upper sideband and the lower sideband. So this question is based on degrees of modulation is over modulation, that is amplitude occur when signal amplitude is dash carrier amplitude. Thank you.